So now we have the challenge of evaluating this, putting the inverse sign back in here. So I put inverse sine of 2/3. There's no way to simplify that. So if I just stick it here, I'm just going to have 2 inverse sine of 2/3. But when I put that inverse sine of 2/3 here, somehow the sine and the inverse sine should cancel out. But you're sort of in a conundrum because although I know, for example, that the sine of the inverse sine of 2/3 equals 2/3 because sine and inverse sine cancel out. So the problem is with that 2 in there, if I do sine of 2 inverse sine of 2/3, all right, with that 2 in there, the cancellation cannot happen. So there's nothing we can do there. There's no way we can reduce it. So what we need to do next is get that 2 out of there somehow. If sine is not a linear function, that means we cannot factor the 2 out, as you guys hopefully already know. All right, so there is a way to get the 2 out, though. If you recall that we once upon a time said that sine of 2x is equal to 2 sine of x cosine of x. So this is how we manipulate expressions to get things that we want. So we want just sine of inverse sine. We don't want sine of 2 sine. So do we have a formula that changes sine of 2 something and enables us to essentially pull that 2 out? Well, yes. So in a way you could say, I could pull that 2 out, but it costs me picking up a cosine, but I can handle the cosine. All right, so that's the manipulation that we will apply next, is we will apply that sine of 2t is equal to 2 sine t cosine t. And we'll do that manipulation before we substitute in the values. So now we're going to have 9/2. What else did I do? Why did I do the 9/2? I did this while the video was off because I didn't want you to see me doing it. No, just because I happened to set this up and then I forgot. I try to get rid of fractions inside my evaluation because I don't want to deal with them. So I factored out a 1/4. 1/4 of 18 is 9/2, and that gets the 1/4 out of here. And since I'm factoring 1/4 out of t over 2, that leaves me with 2t, because 2t over 4 would be equal to t over 2. Okay, so that's how I ended up with 9/2 out here instead of 18, and got rid of all my fractions. Forgot to mention that. All right, so now, right, so we're going to write 2t plus 2 sine t cosine t from 0 to inverse sine of 2/3. So now we'll be able to make that sine cancel with the inverse sine. But we're also going to pick up cosine of inverse sine. And another reason that I think it's important to go over some of these, we've seen this once before, but it's really worth revisiting, that anytime you have a trig function of an inverse trig function and they don't match, like for example cosine of inverse sine, there's a standard technique for simplifying that, which we're going to see in a minute. Okay, so we're going to just plug these values in next, I think. So let's just go ahead and plug them in. So we're going to have equals 9/2. Let's see. Yeah, I just threw out the 0, but I think I want to mention it. So we have 2 inverse sine of 2/3 plus 2 sine of inverse sine of 2/3 times cosine of inverse sine of 2/3. All right, now that's the first term of this. That's just plugging in the inverse sine of 2/3, okay? Now, if I didn't have 0 down here, I would have another one of those, all right? But I do have 0 down here, but you have to check to make sure, does the 0 really make everything 0? If I had e to the x, it would not make everything 0. So when I plug in 0 to 2t, I'm going to get 0. When I plug 0 into this product, the cosine is not going to be 0, but the sine is. As long as one of these factors is 0, the whole thing is 0. This is 0, this is 0, the whole thing is 0. When I plug in 0, that's the huge payoff for having simplified this problem by using the symmetry. Is that I don't otherwise I would have to write all of this again with inverse sine of -2/3, and I would end up with the same result. All right, so now let's see what we can do with that. I think I'm going to break out some steps. So we have 9/2 times 2 inverse sine of 2/3. That's not going anywhere. We're not going to be able to simplify that. Plus, now inverse sine of sine of inverse sine is just going to give me the same function. So we're going to have just 2/3 here. So I'm going to have 2 times 2/3, and then I have cosine of inverse sine of 2/3, and this is the piece that we want to deal with next, is this cosine of the inverse sine of 2/3. So I think I'm going to break that out to the next video. But this is what we're going to deal with next, cosine of inverse sine of 2/3.